Hey, welcome back to Mr. P Helps with Geometry. This is Unit 1, Topic 1, Lesson number 3, and we're going to talk about how to use notation for parallel and perpendicular lines and congruent segments as well. What do you see? So when I look at this, this is very similar to what we did in the last lesson. I see two planes, planes A and B. I see a line going through both planes. That would be line DH. I see point H is on plane A and point D is on plane B. And plane B also has two other lines. It has line CD and line EG, which appear to be parallel, but we do not really actually have any proof that they are parallel. Is there more than one way to name a plane? So as I mentioned in the last video, so we have plane A only has one way to name it, right? Plane B can actually be named more than one way. So it just kind of depends for this question. Plane B could also be named plane using capital letters. Now keep in mind this B is supposed to be italicized. Plane EFD. Now, it doesn't matter what three letters you use when you're naming a plane. When you're naming points, as long as those 3 points are not collinear. The reason why is because if 3 points are collinear, then the plane can be really facing any direction and still be going through those 3 points. But if the 3 points are not in a straight line, then there's really only one flat surface that could cut through all 3 of those points. So that's the reason why it's so important that the 3 points are not in a straight line. Because once again, you could still have that piece of paper going through those 3 points if they're in a straight line, and they could be facing in any direction. Is there more than one? Okay, so how can you describe the relationship between the E, F, and G? And that is they are collinear, as I just talked about a second ago. They are in a straight line. All right, so once again, we are getting into writing notations, perpendicular, parallel, and congruent. So this first one says same length, congruent segments. Segments A, B, and CD are the same length. So here are the pictures. So here's segment AB, here's segment CD. They look very similar, but we know they are because the direction said so. So what I'm going to do is I'm going to put one little mark in the middle of those segments to note that they are the same because they have the same amount of marks. Now, I could have put 2 marks on both or 3 marks on both. As long as it has the same amount of marks, then they must be the same. Point I is in the midpoint. Now, midpoint means in the middle. It's a point in the middle of segment EF. So here's I. So that proves to me that these two sides must be the same, because if I is in the middle of E and F, then E to I must be the same length as F to I, because that's in the middle. So I put 2 marks on both of those to note that those sides of that segment EF are the same. Line K is the bisector. Now, bisector means splits the segment in half. So line K is this line right here, denoted by this lowercase k, is the bisector of GH, meaning it splits this GH in half. Now, I know what you're thinking, because you might be thinking that this segment isn't in the middle of line K. Well, first of all, lines don't really have a middle because they go infinitely in both directions. So technically, I mean, you can get really complicated there when you start talking about infinite. So if I put a point right here, I guess I can make the same case for being in the middle as I can make right here, because there's an infinite amount of left on the infinite amount on the right. So, when we're talking about lines, there really is no middle. But when we have a segment with 2 endpoints, there's a middle. So this line K is bisecting GH, not GH bisecting K. So that's 2 totally different things. So it's actually the GH that I'm going to put 3 marks here and 3 marks here, noting that if K is bisecting it and it's going through point J, then point J technically is the midpoint of segment GH. So both sides, GJ and HJ, must be congruent to each other by definition. So keep in mind, geometry is all about what you can prove. So not assume. There's no assumptions in geometry. I can prove that these 2 segments are the same based upon the information given. All right, so now let's talk about angles. Angle 1 and 2. Here's 1, here's 2, here's 1. So to denote angles being the same, we put little angle marks. Now you can put one angle mark, two angle marks, and sometimes people make an angle mark and then put slashes through them like this. That's just another way of doing the same thing. It kind of keeps it similar to how you do segments. Now that's usually not the way I prefer to do it, but just note that people do that, or they can put 2 marks here and 2 marks here. You will see people doing that as well. In fact, I'll keep it that, even though that's not the way I would most likely do it, I'm going to keep it like that. Angle LJK, L to J to K, that would be this angle right here. I'll put 1 mark, since I left this one 2 marks. And JKL, let's find J. JKL, okay, that's this one right here. 1 mark. So that proves that this must be an isosceles triangle because it has 2 angles that are the same. And we'll talk about base angles and isosceles triangles in the future, but that does prove that. SQ, it looks like that's a ray. It's kind of hard to see. Ray SQ is the bisector of PSR. Now, here's PSR. If ray SQ is the bisector, that means it splits that angle in half. Meaning this angle and this angle, I'm going to put 1, 2, 3, 1, 2, 3. Now, notice that on the same diagram, I have a 1 mark, a 2 mark, and a 3 mark. It's very important that you don't use the same markings for different ones, because if I put 1 marking here, then I would be technically saying that this angle is the same as this one, since all 3 of them have 1 marks, or all 4 of them have 1 marks, and there's no way for me to prove that. So it's very important when you're using the same diagram. Now, if you're on a different question with a different diagram, yeah, of course you can use 1 mark again. But if you're talking about the same diagram and same picture, make sure that unless you can prove they're the same, that they don't have the same marks. Now, I'm not saying the 1 mark and the 2 marks aren't the same. They could be the same. I just can't prove it. Okay, so now let's talk about parallel lines. Segment QR, that would be this one. That's this segment, and PSR, this is the symbol for parallel. Now, the way to do parallel is to put these, what looks to be like arrow markings, in the middle of the segment. That denotes the fact that they are parallel. QP and SR, now I'm going to put 2 markings because I don't want people to think that this one and this one are parallel, so I got to use a different amount of markings. These 2 are parallel. Now, I know what some of you are thinking. You're probably saying, well, hey, these 2 are not parallel. Clearly, that one's slanted, and they're going to hit each other. Now, once again, diagrams in geometry are not drawn to scale usually. So just because they look like they aren't parallel, if they're telling us in the directions they are, then we have to assume that, okay, that's not an assumption, sorry. Then we know, take out the word assume there, I kind of used that incorrectly. So if they tell us in the directions they're parallel, then they are parallel. It does not matter what they look like in a diagram. It's all about what you can prove. We have line AV is perpendicular, meaning it creates a 90-degree angle with TZ. All right, we got all sorts of lines in here. TZ is this one. And AV is this one. Okay, so that proves that this is a 90-degree angle because this line and this line are perpendicular to each other. TW, that's this one. And UA, which is this one. Okay, so I'm going to put a 90-degree mark right here. That's TW, sorry. TW. TW and UA. That's correct. Okay. One special combination, GI, line GI is the perpendicular bisector of segment BF. Here's segment BF, here's GI, and perpendicular bisector. Okay, so there's perpendicular. Now, bisector means splits in half. Splits BF in half means that this and this must be the same. So notice that this set of directions actually told us 2 things. It told us that they're perpendicular, and it told us that those 2 sides of the segment are the same because it's a bisector. It splits it in half. All right, so we have similar questions here. So GH is parallel to FJ, and angle G is the same as angle J. Now, I'm going to do it this way. This is actually the way I prefer. And if I put 2 like this, then they're still the same. So I'm just trying to show you different ways of showing congruent angles. GH and FJ. Now keep in mind this is a different question, different diagram, so it is okay This is not the same diagram, so I can use the same markings. FG, that's F to G, that's this one, and HJ is this one. Okay. So they have to be the same. So segments BO, which is this one, and YB, connecting Y to B, these two are the same. TO, I guess this is supposed to be T here, so I'll put 2 marks here, and YP, oh, T to O, sorry. Wasn't paying attention there. So T to O, which is here, and Y to P, which is here. Oh, parallel. 2 mistakes on the same question. All right, let's try that again. So there we go. So parallel. BD is perpendicular to EA. So here's BD and here's EA. So I'll put a 90-degree mark. Angle A, that's this one, and angle E are the same. So 1 angle mark. Or you can put that little slash to it. Like I said, 2 different ways of doing angles. BD is the perpendicular bisector. Perpendicular means that it makes a 90-degree angle. Bisector means splits it in half. So AE gets split into 2 equal parts. All right, TO is parallel to YP, and that's it. KL is the bisector, splits it out in half. So this is the bisector of MKJ. Well, MKJ is this angle. So that means this side and this side must be the same. Angle J and M must be the same. 2 marks and 2 marks. There we go. Segment CA and OL are the same. Segment CA and OL are also parallel, so I'll just put parallel symbols on the same 2 sides as well, which can be done. So I've got the congruency markings, the notations inside the segments, and then the parallel lines. Point B is the midpoint of TP. Now, that means this and this are the same. It does not prove that these 2 are the same. Because it says it's the midpoint of TP, it does not say that point B is the midpoint of OY, at least not yet. And TO and YP are parallel. And it looks like that wraps us up. Please let me know in the comment section if you have any questions, and please give it a like if I helped you learn something about writing the notations for parallel, perpendicular, and congruent sides and angles. Have a wonderful day, and see you in the next video.